So an antigen is a substance that causes an immune response in specific lymphocytes. The property of behaving as an antigen is antigenicity, and it must meet criteria that's related to foreignness, the size, the shape, and the accessibility. Immunogen is a type of antigen that actually does induce a specific immune response when it's introduced into the body. Some antigens don't fit all the conditions to stimulate an immune reaction. For instance, small polysaccharides that come from the bacterium Haemophilus influenza are foreign and antigenic, but they are too small to trigger a lymphocyte response. The foreign cells and the larger molecules that have greater than 10,000 as their molecular weight are the most antigenic. And these are complex molecules that have several epitopes or molecular fragments that make good immunogens. The poor immunogens are the small, simple molecules that don't attach to a carrier molecule, and those that are just simple, large molecules where it's a repetitive chain of monomers. Now, a lymphocyte recognizes and responds to just a small portion of the antigen molecule, and the molecular fragment is called the epitope. And you see down there the epitopes in green and blue and pink and orange and the dark blue and the yellow. The shape of the epitope fits like a key to a lock in the lymphocyte, and you can see where it binds to the antigen presenting site, and it needs to fit into that specific site. Haptens are just small foreign molecules that consist of a determinate group, and they're too small by themselves to elicit an immune response. And that's what you see here. You have these small molecules in figure A at the bottom that will not trigger an immune response, so no antibodies are produced, but they can bind to a carrier molecule, and that increases their size as well as the orientation of the antigen. So if it's linked to a carrier molecule, it can develop immunogenicity because the hapten will serve as the epitope. Alloantigens are cell surface markers and molecules that occur in some members of the same species but not others. This is what determines our blood group and our major histocompatibility profiles. It's also responsible for reactions to blood transfusions or when we reject organs. Superantigens are potent T-cell stimulators, like toxic shock, toxin that causes a massive release of cytokines, and it leads to cell death. Allergens are antigens that cause allergic reactions, and autoantigens are molecules on our own tissues, and tolerance is inadequate, so it can lead to autoimmune diseases like rheumatoid arthritis. Immunoglobulins, which is represented by Ig. This is a molecule that has 4 polypeptide chains that are connected by disulfide bonds, and all the antibodies have 2 distinct segments or fragments. There are the Fabs, which are where the antigens bind. It's the arms with the antigen binding site, and then there's the crystallizable fragment that binds to various cells and molecules of the immune system, and it can be crystallized in a pure form. So you can see this here. You've got your Fab where they'll bind at these antigen binding sites, and you see that there are heavy chains, and the dark purple's the heavy chain, and then this over here on the side, the light color, that's the light chains. And then down here at the bottom, you see this is the FC, where they'll crystallize in their pure form down here. So that's the basic shape of the antibodies. So if we look at this antibody, we see, again, the light chains are these little short ones on the side up here, and there's the antigen binding sites. And then they can swivel around. This part up here, the Fab, can swivel around at this hinge region. And then down here at the bottom, you've got your heavy chains in the FC area. The Fab antigen binding site, as I said, it can rotate around. It's hypervariable, and it's got a variable amino acid content. And that groove where the antigen binds is a three-dimensional fit, so it has to fit directly for it to be linked. And you can see here, this is a good fit. This on the left, it doesn't fit at all, and on the right it fits but not well, so it's a poor fit.